Share the screen real quick.
Larger than life.
Yeah, thank you. That was quick. You see the screen now? Okay. All right, let's get started. Yeah, thank you everybody for joining. We are going to have our fourth Agentic AI and LCLS training session. The topic is on agentic coding. Although it says agentic coding, but I personally believe it also translates to other type of agentic tasks, and you will see why later very soon. Yeah, so when we work with AI agents, I usually ask myself one question, like what kind of knobs I have in my control to steer the agents. And the answer is, the input, the context. So in today's talk, it's actually about I'm not going to show you a demo of me working with the agent to create something, but it's a pure like a conceptual talk on context engineering. And this talk is highly inspired by another talk called harness engineering, but in the end, it's just context engineering by this guy, Dax Horthy from Human Layer, and also by Jeffrey Hundley, not this guy, that's the guy, who wrote this amazing Ralph Wiggin Loop article, talk about how we can scale context engineering. The links to the video and the articles are in the slides. Yeah, so if you go to slides, click that, you will lead to the video and the blog post. I highly recommend this video and Jeff's blog post. Yes, and in the first lecture, I introduced something called agent breaks. That's how I manage agents from 3 different perspectives. The first one is managing agents' eagerness. Second one is make sure the agents are aligned with me. So the agent-human alignment. And third one is, I guess, agent-specific. So it's called context rot. You don't want to stuff too many things in context window, which will usually make the performance worse, right? And for today's talk, the actual title that I want to use is this: context is the only lever you have to steer the model. What does that mean is agent is something like a stateless machine where the only way to steer this machine is the input. So context in, next step out. I don't know how many of you have watched the movie Memento. It's basically like the Memento character who in the movie wakes up every single morning with a clean slate. So it doesn't remember what's going on in the past, so it relies on the notes in his pocket, also the tattoos, to understand who are actually his friends, who are his enemies, and so on. And that Memento character is just like our AI agent. And hopefully this is not too controversial to say that the quality of the output of an agent only depends on the quality of the context. So we are talking about a context engineering here. And in this talk, I'm going to explain this idea context is the only lever with 3 failure modes. And in the end, I will talk about how to actually scale context engineering from just one like Cloud Code or open code session. So when we talk about context engineering, or what is a good context, it has to satisfy 3 properties, 3 C's. That is correct, complete, and concise. You want your context to be correct, complete, and concise. Because the opposite of that will completely destroy the output. If you have something wrong in your context window, you are actually confusing the model. If you have something missing, that's also bad, but maybe the model can make it up by making some assumptions. Some you like, some you don't. And then noise. If you dump some huge log files directly into the context of a model, I'm not sure if that's actually helpful for solving a problem. Yeah, so I'm also going to associate the 3 C's with the agent breaks that I talked about in the first lecture, in order to manage the correctness, the completeness, and the conciseness of the context. So yeah, let's dive into the first C, complete. What does it mean to have a complete context? Well, I think even in one of the demos I gave last week, I didn't really manage the eagerness properly. So the model, reads some of my instruction and starts to write some files already. So unexpected writing is a behavior of model being too eager and without having a complete context window. But what does it mean to have a complete context window? Well, for it's task specific. So if you undergather context, you're facing the problem of a missing context. But if you overgather, you're facing the other problem, which is you're actually adding noise, right? So here the human judgment actually becomes important. Domain experts' judgments becomes very important. Usually, you have to kind of, by working with agents a lot, to have a kind of mental calibration on is that enough for the agent. There's no way there's no secret I can share with you to kind of automate this process. You have to work with agents a lot to understand what is good enough for a specific task. Yeah, investigate or research before it does anything. And in this case, I'm gonna go back to the eagerness management agent breaks. I use /noeager a lot when I do research, and I also use /noeager a lot when I try to identify gaps in the context. In practice, this gaps analysis can also be combined with clarify. So it's not like there's a fixed pattern. You can do /clarify with gaps. That also works. Otherwise, you do it in 2 steps. You use /noeager, ask it to identify gaps first, and then you do /clarify. It will actually ask you questions. Don't build. Research first. This is the example that I used in the last week when we created the Slack Speak agent. You remember I asked the agent, I copy paste the URL of the Slack Speak website, and I asked the model to just research a few pages and try to have an understanding of what kind of data we are dealing with. Right, so that's the no eager phase. We want to make sure the context window is complete. Next one is correctness. The context window needs to be correct, because otherwise something wrong in the context window is going to be disastrous. It's actually much worse than missing context, because when you have something missing, the model can still make some assumptions to make some progress. It might not be the progress you want, but it will make some progress. Right? When you have a lot of missing wrong context window, actually it's very confusing and misguiding the model. And the momentum character will say this. So yeah, it's similar to like when you are misguiding even human coworkers with the wrong context, people will be very upset. And here is the graph where I kind of want to show this, the errors, how errors propagate and even amplify in agentic coding. So let's imagine you have a few lines of wrong facts during your research. Yeah, there's some sloppiness in the research, just few lines. But when you ask the model to make a plan based on the research, you will probably end up with dozens or even hundreds of lines of wrong planning. And what do those wrong planning do? They will be translated to maybe even thousands of lines of sloppy code. So the sloppiness actually scales across the research planning and implementation dimension. This brings a very interesting discussion that I will discuss later. As a human, where do you want to spend your time reviewing agentic work? Do you only spend your time in reviewing the code? Or do you spend your time reviewing the planning or research? That's an open question. Of course, we still want to review the code, but really reviewing the research and planning becomes increasingly more important. And I'm not sure if we even have a tool to do that. Our GitHub probably will show the diffs for the codes, but we don't have the diffs for the research and planning. Or even whether diff is the right idea to review research and planning. We don't know, so that's kind of the open question. So, but within a kind of single cloud code or open code session, I always manage it with this alignment, using the alignment dimension. Yeah, you look at the slide when you want to know the details, it will be included in the slide. But I'm going to show you just an example that we had last week when we created Slack Speak agent. I use this /clarify quite a lot to identify any gaps, anything that's missing. I use /align to check the scope, whether it's really aligned with me. And I use /approval before it actually go ahead and do things. Yeah, so that's how I kind of manage the correctness of the context window. In this particular case, the model actually is a little bit suspicious about one context. We can see it from the one of the handoff documents we created last week. It assumes that in this case, one specific library in Python has this full text search support, but it's not very sure. So it asks the model, the fresh agent, to actually verify it on S3DF to understand whether this feature is supported. So that is to guarantee that our context is correct. And lastly, for this third C, conciseness. What does it mean to be concise? Yeah, so let's say if you dump something like this, which you often see when you work with MCPs, it's basically a huge JSON file directly dumped into the context. It can be just few lines of JSON, but it can be like I don't know, 4 megabytes of JSON, which is pretty large. But if you look at those contents, it's just like some random identifiers and the URLs. I don't know how helpful they are when you actually when the agent wants to solve the problem with those informations. So these are noise. And agent does perform worse when you have just too many stuff in the context window. There are some studies from the vector database company Chroma and some studies from Stanford as well on the context rot problem. Here I'm just giving a sort of a hand-waving number. If it's the context window is about 40 to 60% full, you need to be worried about your context. And also today's model has like 1 million context window. Here I'm only talking about like a 200K max. So yeah, so that is about like 80K to 120K tokens in the context window. But the real idea is, this is a hand wavy, but the real idea is the more tokens you have in your context window, the more distraction the model has. So if the model can finish a task with fewer fewer tokens, it's always better. And how do we tackle the context rot problem when you just have too many stuff there? We really want to find a way to sort of compress that context window, compress the noise away, just leave me like the real good stuff. And in this case, I use this /handoff a lot. You can have your own handoff kind of a prompt. The idea is to generate a self-contained handoff document so that a fresh agent can work on it. It has to compress away all those noises. In details, I do include these kind of 7 sections in each handoff document. It has to state what the goal is, where we are, and some decisions we made, some things we don't want to include, and some load-bearing assumptions, which, if not true, if they are wrong, it will collapse the entire work, and some open questions and references to the materials. So that's what I include in every handoff document. You could consider using this. So the /handoff in our open code basically uses this, but like I said, the important thing is the idea. If you know you need a handoff, you can just write a single like prompt for that. To just show you what the handoff document looks like, this is the one I find which is the shortest that can fit actually in one slide. That's the stage 3 like ingestion part of the task that we did last week. A handoff can outlive a session. Now so now we're talking about something that can happen across sessions. It's actually a good segue to talk about scaling. So how to scale context engineering beyond just one session. So when I think about scaling, there are really like 2 axes. One is across time, and the other one is across people, across the entire team. Personally, I'm more familiar with across time scaling. So I do include some examples from, I mentioned human layer before that talk about across people, but just to give you a heads up, I'm more familiar with across time scaling, so I'm going to talk more on across time scaling. Across time scaling is kind of simple in its idea. You have a series of handoff documents or series of tickets. You just ask one AI, hey, just work on the first ticket. And after it finishes, launch a new agent, work on the second one, launch a new agent, work on the third one, etc. But you might wonder, well, Colin, you told me the agent always starts fresh. It doesn't have a memory. Well, if you do want, these fresh agents to work together to accomplish a task, a bigger project, a bigger task, you can add some memory mechanism. The one I use these days is essentially kind of append-only notebook. I never modified it, so append-only. If you have something, append it there. If it's a detailed document, I will still use append-only notebook, but with maybe a markdown file explaining the details, and let the notebook reference that markdown files. Because if you don't do that, if you just solely rely on markdown documents, and after a week, you will see something like this. You will have like 30, 40 markdown files in your folder. And the worst thing is you don't know which one actually which is already outdated. And then if the agent consumes that, it's wrong information. And remember, if something wrong in the research will be amplified to thousands of wrong code, right? So this becomes manageable. But when you combine scaling across time with some memory mechanism, you can scale it like this. You phrase your project, let's say, into a project that with 20 Jira tickets or 20 GitHub issues. Each issue is kind of bite-sized. Hopefully you can, the agent can finish each issue or each task with, let's say, 120K tokens. And you can just ask an agent, create a new agent, work on a ticket. After that, you create another agent, work on the next ticket. And if you expose maybe just a little bit of metadata of each ticket, the agent can actually pick which ticket you want to work on. And you just scale this across time. Yes, it takes time because you're working on one ticket at a time, but some tickets, they are kind of independent. They are dependent on each other. So you don't really want to do something too fancy, like parallel agents, and then you have a nightmare merging the results. Yeah, so this is a pattern I think that would be very helpful in like much bigger tasks. You can solve those. You can try to at least tackle those problems with the like time-wise scaling. Break down your problem into tickets, and ask an agent to work on one ticket at a time. And also, by the way, because of the memory, the new fresh agent understands which tickets have been done, and what are the kind of good patterns it learns, and what are the bad patterns it learns. Yeah, so agent in some way it learns over the course of working on those tickets. Cross team, it has similar ideas, except the memory is sort of a shared. You do want some shared context substrate so that it's easier to onboard new members. In one of the examples Human Layer provided, they have interns come on board the first day and already are able to ship like 2 pull requests. And after a week, they ship like 10 pull requests because of those shared kind of context substrate. But you do have to be careful about playing with parallel tasks because they have to be independent. Otherwise, you better stick with time-wise scaling. Otherwise, the merging will be kind of nightmarish. Okay, so that is actually, roughly speaking, everything I want to say. You only have one levers when you work with AI agents. You want that is the context window. You want to have the 3 C's for your context. The context has to be complete, correct, and concise. And this is the slide I think that can cause some controversy. I sort of alluded to it before. So if we talk about agentic coding, we have this research phase, planning phase, and the coding phase. And everybody knows these days we can see we can have 20 PRs in a single day. And as a reviewer, you become very exhausted because our attention is limited. So where you should spend your attention? We do still want to read the code to some extent, but can we outsource some of the reading of those details to AI so that you don't always just not bury yourself into the details? Is it better to review the plan? Is it better to review the research? I think directionally speaking, my answer is yes. I would love to review the research and plan when I see the code. But unfortunately, I don't think today we even have tools for that. When you submit, when you see a PR pull request coming in, you see the code changes and maybe some comments from the people who submitted the PR. These days with AI PRs, it's kind of basically essays. So yeah, it's challenging. Maybe we need new tools to review research and review plan instead of just reviewing code. So if you are able to build something like that for, let's say, for Slack, I think that would be very that kind of thing will be very. It's going to be kind of revolutionary if you can build something like how to review the research plan along with the code. I think some sectors of the industry might already be looking into it. If anybody learns tools that can do that, please let me know. I would also like to explore those options. Personally, I'm already kind of exhausted in looking at PRs that have maybe thousands or tens of thousands of lines of change in one PR, and the PR itself is like a messy. Because I would rather just review the research and plan. I would just ask AI to review the details. Yeah, so 2 patterns, but actually it's the same thing. You scale across time or scale across team. I think I'll end the talk here. I really just have one kind of idea to tell, which is the context is the only lever. And by engineering the context window, I think you will be better at kind of agentic tasks, doing agentic tasks like agentic coding. All right, so yeah, I'm gonna open to some questions, and hopefully, because I think there are some controversial topics involved in this talk, especially the last one. So I'd like to open. Yeah, I'm open to kind of discussions. Thank you. Yeah, so
Maybe I have a question for
Yeah.
something that I would. So you were talking about context window. What if it just, if you're using AI to do like data mining, right? Like let's say we really just want to look at all of the proposals from the last 5 years, all of the theme time proposals for the last 5 years. It really is just a lot of information.
Yeah.
And is this the kind of thing where you would try to feed it in chunks and have it write? It's like, okay, what are the research trends for this specific run or this specific I mean, it's like, what if what you needed to deal with and process is just very large by itself?
Yeah, so you kind of have to break it down because you don't want the. So I'm going to kind of refer to this slide. Oops. Here, you sort of still have to break it down. You could do it with time-wise scaling. You ask one AI to understand one proposal first, and then sort of compress that proposal into something manageable when you scale it up to like 5,000 proposals. And then you have maybe progressively merge those output from these AIs. Otherwise, yeah, because the other school of thought is the current AI has like 1 million context windows. Some have 2 million, some have 2 millions. Let me just stuff everything into the context window. Yeah, as you can tell from the talk, I'm not in favor of that idea, because you really don't want to stuff everything into the context window because of the context raw problem. So I would still recommend doing some sort of compression first with AIs, and then ask the AIs to work on this kind of compressed documents. Because sometimes you don't really have all the details to decide, whether this proposal is a good one. Yeah.
And I guess because I was thinking that if I were to, depending on what the final question is, you would want it to ingest all the proposals differently. I mean, there would be one, it's like, okay, what are the science trends? Maybe that's too broad of a question anyway. So you would want to ask very specific questions about like, okay, is this research,
Yeah.
is it using more spectroscopy than scattering or something like that? So you would ingest, because I guess one thing that it's tempting to do is to have it ingest everything and understand everything on all dimensions, and then ask it any questions you want. But I think what you're talking about now here is like going from the specific question, and having it ingest things with a specific thing in mind, and then you can compress it. So that means you just have to do everything over again for each individual question you want to ask.
And at that point, you probably don't want to do, like, if proposals, I guess proposals are they have some weak correlations, but most of them we can assume they are independent. So you can probably use like the other dimension to scale it. Just ask multiple agents to work on different number of proposals, and somehow kind of merge later. And you can do. Then you probably don't have to do it all the time to kind of pre-process those proposals. You pre-process it once, you saved it somewhere, and then you leverage the compressed information to answer your questions. If you realize something is not good enough, then you think about how you want to compress those proposals, and then you do that later. At that point, you probably already have scripts to do that. So.
Are the context windows expected to increase?
It's up to how cheap is the memory, I guess. So they can increase, but until we see that the context rot is kind of mitigated by the model companies, we really shouldn't trust that it can process all the 1 million tokens faithfully. So so far Yeah, it's like similar to human, more stuff in our head, more distraction.
Can you go back to your 7 parts of a handoff document?
Yeah, sure. Seven parts of the handoff document. This one?
So why do you want to include all this? What happens if you just ask the AI, can you give me a handoff document?
Yes, you can do something like that, but make sure to include like the handoff document has to be like self-contained.
But what's the point of all these? Like, why do you need all this?
Oh, this is just a pattern I kind of actually this pattern emerges from the model itself. I use handoff too much, and then as I see the model, like especially the newer ones, prefer to have those. So this might change when the new model comes up. But the only idea that's kind of constant, that's not changing, is the document should be as self-contained as possible. Because if not, the next model, the next agent with fresh context window will probably make assumptions. It probably will have to do a lot of research. And by the time it gets to work, maybe 100K context is already gone. Right? So you want to make it as self-contained as possible.
In the research phase, I'm kind of confused a little bit on this. Is this also supposed to be within the plan kind of agent on like if we're using open code sandcode, or maybe you use a completely different AI to do our research? Maybe we've been researching this thing for years and we have, been using multiple, online and other references. Or like, are you saying like the plan mode, you would like research in the plan mode and then also plan in the plan mode? Like, could these be combined into one? I'm just kind of.
Yeah, so some harness does that. You could just work in the plan mode. And by the time before it generates a plan, it will, like usually it will trigger sub-agents to do research. That's included in Cloud Code, for example. But I just, like personally, I don't like to work in the plan mode a lot, because every time you work in the plan mode, you ask it to do something different, it would regenerate the plan over and over and over again. I personally don't like that kind of behavior. I want to kind of isolate the research phase from the planning, so that by the time I get to the planning phase, the sub-agent doesn't really have to do a lot, and because it already has most of the things that I think are important to the final problem solving. Yeah, so and that's also kind of a, people say plan and implement. There's also quite a lot of people, including the two I cited before. They also do like research planning and implement. So I would say it's more intentional. It means the research is important. Otherwise, you just relies on the harness. What if the harness changes its behavior? Right. So the key thing is you need to know the model requires research before it plans things and before it writes any lines of code. Yeah. So if you have this idea, then regardless which harness you use, I think you will feel at home essentially. Yeah. So we still have 15 more minutes left. If there's questions, I'd like to also try to discuss.
That way, decide what we're going to put in the context window. We already have a long discussion with the AI, and then
okay. So you have a long discussion with the AI already. Let's say it already takes up 100K tokens, and then how to decide is it good enough, or
how do you decide what we keep for following questions?
It's a combination of your own judgment, and also you sort of can do it mechanically. Like you literally can ask the model with, let's say, /clarify. Do you see anything that's missing? Do you see anything that's confusing? And the model will, based on what it has in its context window, it will ask. It will provide some feedback to you. But I don't want to diminish the the importance of your own judgment, because you have solved many problems before. So you have, let's say if you solve this problem by yourself, do you think it's enough context? I personally ask this question a lot when I work with when I work with agents. If I'm personally solving the problem without AI, how would I go about it? I would do a lot of Google search, copy paste some code from Stack Overflow, right? So adapt to the code, things like. But at least I have the. At least I understand what is missing. So human judgments will be quite important in that case. And by the time after you research, it's already 100K tokens gone. You probably want to do some handoff, so kind of compress it down. And I don't know if you encountered the compaction tool that's built into those harnesses, like Clockwood has compaction.
I found it in Cloud Code, so
Yeah.
I using this VS Code harness with Cloud Code, and they automatically do compact.
Yeah, so I don't know what's the state of the automatic compaction now, but when I say compaction, I really want something that I can hand off to a fresh agent. That's the goal. I don't just want want the harness to remove, let's say I dumped some log files there. I don't want the model just to remove those log files. I want it to be intentional, like intentionally make a handoff document for the fresh agent. Thereby, I really, really, really don't like a compaction. I only use it when I started using Cloud Code. And I gave up very early on. I don't really like compaction.
Sometimes I try to debugging for deep code, so ask it debugging, and then it will keep searching the issues from file to file, and then after for a while, then it trigger this auto compact.
Yeah, because it's about too full. The model from a few months ago only has most of them, except Gemini, most of them only have 200K budget for account. And it doesn't mean you can actually use 200K, because they're a 40K reserved for the compaction. So the only available tokens you can work with is maybe 160K. So. Okay, so we have some questions online. All right. Yeah, so I'll be staying for a few more minutes. If you have questions, I'd be happy to discuss. And thank you everybody for joining. And overall context engineering. Oh, yeah, we have that.
You want to stop it.
Stop what?
Recording.
Is it? I guess it's stopped.
Nice.
I think I may have stopped it. Yeah, we have the link. So I don't know if Fred forwarded this before this PS agent site. If not, I will copy paste to here. Are you in this channel? Also station live. Okay. Yeah,
It's in there?
search also station. Yes, it's there.
Oh,
So much better.
all right.